This is a lesson on using using counting techniques. So we're going to use things like factorials, permutations, combinations, and all those type of things. Now most of these questions I'm going to just leave it in permutation form and not actually calculate the answer. You can do that on your own calculator. Stephen and Jason are both runners. In an 8-person race, what's the probability that they start side by side? So the first thing I'm going to figure out is on an 8-person race, how many people are there in order? And that would be 8 factorial, putting them in all in order, 8 people, an 8-person race. Now Stephen and Jason going side by side, what I'm going to do is I'm just going to do a little calculating here, figure out their successes. So 8 people in a race, 1, 2, 3, 4, 5, 6, 7, 8, okay? I want to treat Stephen and Jason as one person. Now they can move anywhere in this race to take up one of those spots. So then I'd have 1, 2, 3, 4, 5, 6, 7 things to put in order if I'm going to treat them as just being one. So that'd be 7 factorial. But Stephen and Jason could go Jason first, then Stephen, or it could go Stephen, then Jason. And every one of those spots they go to, the order could flip-flop back between who they are. So it's going to become 2 times 7 factorial, because there's 2 scenarios for each one of those spots. So 2 times 7 factorial. Now 2 times 7 factorial is really 2 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Divided by, and then 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now when you're dividing and you have a top and the bottom are the same, they can just simply cancel out. So the 1's cancel out, the 2's cancel out, the 3's cancel out, the 4's cancel out, the 5's cancel out, the 6's cancel out, the 7's cancel out. I'm left with just simply 2 over 8, which is 1/4. There is a 1/4 chance that Stephen and Jason are side by side in the race. Okay. Next question. A teacher is doing a new seating plan for 17 students using 25 desks. What's the probability that Calvin is in the first seat? So if I have 17 students, 25 desks, the order matters when you're doing a seating plan. So I have 25 desks, I'm not using them all, I'm only seating 17 students, 25p17. Probability that Calvin's in the first seat. So I want to place Calvin there. Calvin, you're in the first seat. Then I have only 16 students left and 24 desks to place. 24p16 for the numerator. So this is the probability that Calvin is in the first desk, which is just simply 24, because that 1 multiplies by 1, doesn't really change anything, doesn't need to be there. 24p16 divided by 25p17. And you can put that in your calculator to figure out what that is. Okay, it'd be a pretty small probability. Next question. A focus group representing students at a school is to be made up from 8 grade 12s, 7 grade 11s. The focus group is to have 5 members. What's the probability that they're all grade 12 students? So my entire focus group has 15 people to choose from, and I need 5 of them. I'm using combinations, choose, because the order doesn't matter who gets put into the group first. It just matters that they're there in the group. It only matters, it would become permutation if the different group members have different roles, and then the order matters. But here they don't, just matters in the group, so it's 15, choose 5. Now they're going to be all males, so I'm going to need 5 males from the 8 available. So it become 8, choose 5 for my numerator. So this is my probability of all males. Equals 8, choose 5, all males, divided by 15, choose 5, that they are, sorry, not all males, all grade 12s. Well, I don't know why I'm saying males. 8, choose 5, they're all grade 12s, divided by 15, choose 5, that they are out of the entire group. Probability that they're not all grade 12s. Now that means you could have 1 grade 11, or 2 grade 11s, or 3 grade 11s, or 4 grade 11s, or 5 grade 11s, or 6 grade 11s. Well, no, you can only have 5. You're only going up to 5 members. Easier way of doing that would be the probability, so grade 12s, if I go 100% minus the probability of grade 12s, of all grade 12, of them all being grade 12. So I take my answer from A, so I go 100% minus my answer from A, and whatever that was that you got in your calculator. Now will give you the probability of them not being all grade 12s. Okay, you just took away what it was of them actually being grade 12s and take away from 100% and will give you the probability of them not being all grade 12s. Probability of 2 grade 12s and 3 grade 11s. Okay, that's what I want for this scenario. So again, over my total, 15, choose 5. There are 15 students to choose from, 8 grade 12s, 7 grade 11s. I need 5 of them. And what's the probability of them 2 grade 12s and 3 grade 11s? So the grade 12s, if you look back, there are 8 grade 12s to choose from and 7 grade 11s. So I need 2, out of the 8, so 8 choose 2, that's my grade 12s, times, and then my grade 11s, there were 7, and I need 3 of them. So you have 2 grade 12s and 3 grade 11s divided by your total. Okay? And again, you put that in your calculator and you get those numbers and you work with them. Flipping a coin. What's the probability again? 2 4s in a row. Again, 4 tails in a row. So probability of getting a tail equals 1/2. Now I want to get 4 tails in a row. So that means I'm going to have 1/2 times 1/2 times 1/2 times 1/2, which is 1/16. Okay, you had your first tail, then you had your second one, your third one, and your fourth one. You had to multiply them all together because you had first one and second one and third one and fourth one. Now, in either way I could have done that is 1/2 to the exponent of 4. Same thing. Okay. I'm going to roll 2 dice. What's the probability of either getting a 7 or a 2? Now, 2 dice, if I get a 2, that means I have only a 1 and a 1. Okay, there's only one scenario of that happening. So it'll be 1 out of 36 of me getting a 2. If I'm going to roll a 7, you could have had a 3 and a 4, a 4 and a 3, a 5 and a 2, 2 and a 5, 1 and a 6, a 6 and a 1. A two-dimensional grid can also help you visualize it. There are 1, 2, 3, 4, 5, 6 out of 36 total different scenarios of me rolling 2 dice and getting a 7. Now I said it'd be 2 or a 7. Or means I want to add them up. So I have 1 out of 36 plus 6 out of 36 equals 7 out of 36 is the probability of getting a 2 or a 7. Last question. You invite 7 people to a party. They all said they might come. What's the probability that they all actually show up? So they all said maybe. So they might come or they might not come. Yes or no. Now you invite 7 people. You could have 7 people invited and nobody show up. You could have 7 people invited and one person show up. And all the different scenarios that one person show up, who it is, depends on, it changes all the different outcomes. You could have 7 and then all the different scenarios where 2 people show up. And it doesn't matter what the order they show up, just the fact that they show up. That's why we're using choose. All the way to 7, choose 7. These are all the total scenarios. Now, you know this is the 7th row of Pascal's triangle, and it's the sum of the 7th row of Pascal's triangle, which gives you 2 to the exponent of 7 for all the different scenarios. So what's the probability that they all show up? Well, there's only one way that they all show up, and that's them actually all arriving, over that 2 to the exponent of 7. Now that one scenario is 7 choose 7. 7 choose 7, you put it in your calculator, is 1. So 1 out of 2 to the exponent of 7, which is the sum of that 7th row of Pascal's triangle, is your answer of the probability of them all showing up. Okay? This is a lesson of probability using some of the counting techniques like permutations, combinations, factorials. Thank you very much.